Assalamualaikum and greeting to panels and member of audience. My name is Aiman Sharimazni and I will present my research poster which is entitled of Microbial Flooding in Acidizing of Sandstone by Bacillus Licheniformis species. This is my research poster and I will go through chapter by chapter. First, let's start with the abstract. Strong inorganic acids such as hydrochloric acid and hydrofluoric acid were used in the acidizing. So, what is acidizing? Acidizing is a process where the strong acid used to improve the rock permeability. However, the use of the strong acid comes with a lot of problems. Therefore, a hypothesis was made whether it is possible to replace the acid used by using organic acid that produced by Bacillus licheniformis. The experiment was conducted by using two types of medium, which were commercial medium CM and defined medium DM, to test the acid producing condition for the microbes. The variable for the experiment were the salinity, where the salinity will alter with 0%, 1%, 2% and 5% salinity. The mediums were pipetted with the Bacillus licheniformis and then incubated for 24 hours, 48 hours, 72 hours with a constant temperature of 57 degrees Celsius. Let's move to introductions. As I mentioned before in the abstract, acidizing was used to improve the rock permeability. After a long producing time, the reservoir characteristics such as reservoir pressure and fluid viscosity may change over the time. Therefore, acidizing process need to be done to stabilize the oil production. There has been a trial by Shafiq in 2017 of acid combination and different concentrations to acidify the sandstone where the mud acid was produced, which is a mixture of hydrochloric acid and hydrofluoric acid. But it has a catch. Al-Harthi claimed that it was consumed too soon when the reservoir temperature was above 94 degrees Celsius. Besides, this method also causing corrosion to the wellbore equipment. The problem observed by using strong acid were precipitations. These strong acid overreact with the reservoir rock and causing the fluoride silicates, fluoride aluminate precipitations. Calcium difluoride was one of the byproducts of this reaction, which was low in the solubility that making it highly precipitable. Acetic acid and formic acid were produced by Bacillus licheniformis under optimal salinity, pH and temperature. These organic acids could present the precipitation. So there's come a questions. Is it really possible to enhance oil flooding and avoiding the problems by using this organic acid? The objective of this experiment was to identifying the optimal salinity for acid production under defined medium and commercial medium by the Bacillus licheniformis. Next objective was to measure oil recovery by using conventional acid and organic acid produced by Bacillus licheniformis. As for the microbe culturations, two mediums were set with different salinity as mentioned before, which resulting in 8 sets of samples. The pH then tested every 24 hours for each sample and the data were recorded. The lowest pH medium then be selected to be used in the oil displacement test. For oil displacement test, 2 sets of sample were used to test the oil recovery where each set will be injected with different medium, one with the hydrochloric acid 10% and one with the BL mixture. The fluid extracted then recorded and oil recovery been calculated. The data then be plotted as will be discussed in the next chapter. As for the result and discussion, the first stage would be the microbe culturation. As you can see from the picture, after 24 hours of incubations, there was slightly thin layer of plastic like substance or polymer that produced by the microbe. It was proven that the microbe were cultured and the reaction was occurred. The incubation then continued for 72 hours, which resulted in a very thick biofilm. When it comes to the pH of the mediums, all of the medium had initial pH of 7.8. The commercial medium, when exposed to 5% salinity, becomes slightly acidic with a pH of 6.8 after 24 hours incubation, but it quickly returned to the alkaline solution with a pH of 8 at the end of the incubation. As demonstrated by the data, all of the medium become basic or alkaline at the ending of the incubation period. This is due to the fact that commercial medium only contain basic nutrients which allow the microbe to grow but did not allow them to produce acid. Generally, rapid glucose metabolism by Bacillus licheniformis for mixed acid fermentation was observed during the first 24 hours of incubation, resulting in an acidic culture during the first 24 hours of incubation. Following 48 hours of incubation, it was discovered that the pH value had increased. In the most cases, this was caused by the lack of glucose, which caused the acid producing mechanism to shut down completely. On the other hand, For the DM mediums, all of the mediums produce acidic conditions after incubations. pH of the 5% salinity medium produced was 5.8 after 24 hours incubations. At the end of the incubation period, 5% medium showed the lowest pH of all the mediums, which was 5. A monosaccharide, glucose, was present in the medium composition, and a polysaccharide, which was a soluble starch, was present in the defined medium. The acid-producing mechanism of the microbes were dependent on these two components. Monosaccharide is well known for being easier to digest, enhancing metabolism and potentially shortening the time required for the microbe to perform their mechanism, whereas polysaccharide, which is difficult to digest, was theoretically playing a vital role in maintaining performance for a longer period of time after glucose was depleted. For the oil displacement test, there were two sets of sample used to study the oil recovery. The data shown were the properties of the samples. The porosity was 39% and 22% for the SP1 and SP2 respectively. The initial oil in place OOIP for SP1 was 99% and 93% for the SP2. From the graph, the oil recovery after water flooding by injecting BL medium was increased by 60%, while only 50% by hydrochloric acid flooding. As for the BL flooding, this could be due to small amount of biofilm produced that may plug the pore, thus increase the oil recovery. The highest oil recovery for this injection was 60% and the plateau was achieved. This pack then sealed at the end by using normal clips to be incubated for 3 days in 37 degrees Celsius incubator for the next phase. From the graph, it was proven that BL flooding after 72 hours incubation could increase the oil recovery up until 77%. The maximum recovery was 32% from the start of BL flooding. On the other hand, the oil recovery of hydrochloric acid flooding after 72 hours was 70%, which was 20% increment after water flooding process. In conclusion, by using defined medium as a medium for culturing the Bacillus Licheniformis with a salinity of 5%, the respective pH of the acid produced by BL was 5. This acid mixture then be used in the oil displacement test to make a comparison with the conventional acid HCl that produced 77% oil recovery for the DM mixture and 70% for the HCl flooding. By comparing these both data, it can be concluded that organic acid produced by Bacillus Licheniformis can be used to replace hydrochloric acid in the acidizing of the sandstone. So that's all from me. Thank you.